All right, the distance formula and midpoint formulas. The distance formula comes from the Pythagorean theorem. So you pick a point. We're going to call this point x1, comma, y1. Just some, or y1, just some generic point. We'll pick another point over here. We'll call this x2, comma, y2, just a second point. So the little subscripts are just saying first point, second point. We want to know the distance between those. There's a formula that'll do that. But really it comes from the Pythagorean theorem. So what you do is you just complete the right triangle. And then you say, hey, how far is it from here down to there? Well, that would be the difference of the y's. So it's y2 minus y1. And the same thing here. How long is this orange side here? Well, this orange side is x2 minus x1. All right, and we want to know d, the distance between the 2 points. So d squared is equal to this side squared plus that side squared. So it's x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Then we take the square root. D is equal to the square root x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So basically what you do is you subtract the x values, square them, subtract the y values, square them, then take the square root, and that's the distance between any 2 points on a flat surface. Midpoint formula is really just an average. So you pick some point, x1, comma, y1, and you pick another point out here, x2, comma, y2, right? If you want to know where the center point is, you just average the points together. So what is an average? You add together the two coordinates. So you add the x's together, divide by 2, and then you add the y's together and divide by 2, and that's it. All right, so here are the examples. The first example says, hey, is this a right triangle? And then find the area. So the way to tell that it's a right triangle is this side here needs to be perpendicular. So the way you tell that it's perpendicular is by the slope. So this goes up 2 and over 1, 2, 3, 4, 5. So it's up 2 over 5. That's the slope on that side. Now we look at the slope here. So you go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you go down 10, and then you go over 1, 2, 3, 4. So you go down 10 and over 4. So that's negative 5 over 2. Reduce the fraction. So these are reciprocals of each other. They're negative reciprocals of each other, which means they are indeed perpendicular. All right. So now we need to know the area formula for a triangle is 1/2 base times height. So this right here is the base. This is the height. You just have to kind of envision it turned around this way. So there's the base, there's the height. Or if you want to, this could be the base, that could be the height. Either way. So we do from here to here the distance. So we subtract the x's. So it's negative 6 minus a negative 1. Negative 6 minus a negative 1. And that gets squared. Plus, subtract the y's. 3 minus 5. And then square that. Take the square root of the whole thing, and that's equal to the distance. So the formula again, subtract the x value, square, plus subtract the y value, square, take the square root. So this would be a negative 5 squared, to be 25, plus 4, square root of 29. So that's this distance here. Now we're going to do the same thing over here for the second distance. So this distance I'm calling the base. And then this second distance is the height. All right. So we're going to subtract the x values, so it's -1 minus 3, -1 minus 3, quantity squared, plus subtract the y values, 5 minus a -5, quantity squared, so it's this minus that. So it's 4 squared, which is 16, plus, that's 10 squared, which is 100. Okay, so the answer is the square root of 116. That would be the height of this. So the area is 1/2 base, which is the square root of 29, times the square root of 116. So we can type that into the calculator, make it a little nicer, decimal of some sort. So we get 0.5 times second square root of 29, push myself forward, second square root times 116 equals 29. It is 29. Well, that's crazy. So the answer is 29. Ba-boom. All right. Now, baseball season's almost over, but we can do a baseball problem. It says baseball is a diamond. It's 90 feet on a side. What's the distance directly from home plate to second? So the catcher's got to throw it that far. So this is the right triangle right there. I'll draw it out here. So it's a right angle there. It's 90 here and 90 here. You don't really need the distance formula on this. You just need really need to do a Pythagorean theorem, because we know that this minus that is 90 and that minus that is the 90. So square root of 90 squared plus 90 squared is equal to the distance. So it's basically just a squared plus b squared, and then take the square root to get the distance of the hypotenuse from there to there. So second square root, 90 squared plus 90 squared equals 127 feet. So D is 127.279 feet. All right. Last example. And then here are the that's bad. Here are the problems that you can try. Right here. These are the ones in the book. I'll put it on Google Classroom. All right, a Ford Focus and a Freightliner truck leave an intersection at the same time. The Ford Focus heads east at a speed of 30 miles an hour. So distance is equal to rate times time. So they're heading east. This is the Ford Focus. So their distance is rate, which is 30 miles an hour, times time. So 30t is their distance. And then the truck heads at an average of 40 miles per hour, and they're going which direction? Oh, south. So they're going 40 miles an hour. So they're going to go a little bit farther distance. So this would be 40t. And it just really wants to know how is this distance changing right there. Okay, so again, this is like the distance formula, except for it's with a variable here. Okay, so distance is this side squared, so it's 30t squared plus 40t squared. Take the square root. So D is, that'd be 900 t squared and 1600 t squared. Square root. Put those together. So then this would be 2500 t squared, putting together our like terms. So then the distance is 50t. 50t. So we wanted to know an expression for their distance, find an expression for their distance apart at the end of t hours. So this one's going 30t, this one's going 40t, but how far are they being separated by each other? Well, they're being separated by 50t. All right? So here's your problems to enjoy. Good luck.